Okay, let's look at the rest of page 55. So solving multi-step inequalities. Multi-step inequalities are a lot like equations. So we're going to use the same process, which is to isolate the variable. So we're going to do the reverse order of PEMDAS, our typical order of operations, but we're going to use basically undo things. So we're going to use the inverse operation, addition instead of subtraction, subtraction instead of addition, etc., to kind of undo the inequality, to simplify it. So it works basically the same as an equation, except for one important new rule. Whenever you multiply or divide both sides by a negative number, only for negative numbers and only for multiplication and division, then you flip the inequality sign. Must be flipped in order to keep a true statement. However, if you add or subtract a negative number, it just stays the same. So some examples. Example 1, we have 4p plus 5 is greater than 29. So we're basically going to solve this the same way we would solve 4p plus 5 equals 29. I'm going to, let's see, I've got a p term and 2 constants. Let's move this constant over there. Undo the addition. Now I have 4p greater than, subtract this, I get 24. But I want p by itself. Notice I did adding and subtracting first. Now I'll multiply and divide. So I'll divide by 4 because this is multiplied by 4. Do the opposite. I divided by a positive number. Don't flip the sign. I just get p is greater than 6. P is greater than 6. So once you have that, we'll graph it. Here's 6, 5, and 7. We've got our dot. Is it open or closed? Do I need to shade it? I do not. Which way does it go? Let's see. I've got my variable on the left, so I can use this for my arrowhead. It's going to the right. P is greater than 6. Okay? Let's check 2 things. We're going to check the end point or the critical value. Remember those mean the same thing. Oops, or the critical point. You can call it that too. The critical value of 6 is, if I plug in 6, is this true? Go back to the original equation. 4 times 6 plus 5, is that greater than 29? Now we really have a question mark. This could be false. In fact, it is. 24 plus 5. I want to know if that's greater than 29. Well, no, it's equal to 29. But I'm being strict here. I'm saying it has to be greater. So 29 is not greater than 29. This is a false statement, and so it should not be shaded at the point 6. And indeed, it is not. Now I'm going to check 0. I'll do that right here. So check 0. I have 4. Again, I just choose 0 because it's easy to plug in. You could choose 7 or 5 so that they show up on the graph. That would be reasonable too. Or you can choose a really big number or a really small number, so it's really clear to you. All of those are fine. 4 times 0 is 0 plus 5 is 5, so I have 5. Is that greater than 29? Well, no, it's not. That's a good looking sign. So 5 is not greater than 29. This is also false. 0 should not be shaded. So 6 should not be shaded. 0 should not be shaded. And in fact, 0 would be way over here. It is not shaded. So we did it correctly. Not only did we find the critical value, whether it's open or closed correctly, but we figured out which way the arrow goes. Because 0 is false, so the arrow goes away from 0. Let's look at example 2. Let's skip that for a little bit. Okay. 15 halves plus x is greater than negative 37 over 4. Got my fractions again. They're not terrible, and x is isolated, so I could see leaving them alone, but personally, I'd rather get rid of them. Let's multiply by the denominator I'd use if I were adding these, which is 4, the least common multiple. So times 4 over 1 times 4 times 4 over 1. And I have, these can simplify a little bit, so I get 30 plus 4x. Then I'm going to say that that is greater than, I didn't multiply by a negative, so I can still do that. These cancel, negative 37. Notice it's negative 37, but the multiplication was by a positive number. The sign stays the same. Okay, now we have something that looks a lot like that. So take a moment, see where you go with that. Yeah, it's not quite as nice. As always, you can pause. Let's get that 30 out of the way. I'm left with 4x is greater than negative 67. Now I divide by 4. Above I multiplied by 4, so I'm undoing something that I already did. But that's okay, it made our lives a little easier for a while. So we have just plain x is greater than negative 67 fourths. And negative 67 fourths is the same as negative 16 and 3 fourths. Feel free to review how to do that. It's been a while, basically 4 into 67, 16 times the remainder 3. Okay, so now I have my number line that I'm going to draw, but negative 16 and 3/4, where does that go? I like to say, well, it's between it's between negative 16 and negative 17, or I should say negative 17 and negative 16. Right, so let's put them both on here. Negative 17, negative 16. Over here would be negative 18. Now 16 and 3/4 is almost 17. I'm going to put my dot here. Shaded or not? Not shaded. This points right, so we'll point right. And then you're going to check negative 16 and 3/4 in there and see if we get a true or a false statement. Hopefully it's false because this is not shaded. And then again, I tend to choose 0, so we'll plug in 0, and 0 is going to be shaded, so hopefully we get something that's true. Okay. Let's look at a couple more examples. Okay. So example 3. Negative 6p plus 14 is less than or equal to negative 58. Go ahead and solve this one on your own. Works out pretty nicely. Be sure to solve it, graph it, and then check the critical value and check 0 or another value. Any other value will work. So example 4. Third x plus 3 plus 1/2 greater than negative 9 halves. Again, I would get rid of the fractions. When you do that, remember that you're going to multiply this piece, and this piece by whatever you decide you need to multiply by the least common multiple of 3, 2, and 2. You do not need to multiply the inside. They already get the benefits from this multiplication outside. Example 5, 2 times 3x minus 5, so we've got some distributing to do, less than or equal to 4x plus 6. Once you distribute, you're going to solve this very much like an equation. If you divide or multiply by a negative, remember to flip that. You may not, depending on how you set this up. And let's get number 6 up here. 5 halves plus 7x less than or equal to 4x and it's 7 halves. Okay. So I will go ahead and tell you while I'm thinking of it that one of these, the answer is going to be like a is greater than 0 or a is less than 0. So instead of getting something like we got on the other page where it was negative 16 3/4, it'll be 0. That's okay. The only thing we have to be careful of is finding that other value. I can't check 0 twice. So 0 is the critical value. Then I'm going to plug in something else that's easy. Maybe 1, maybe 100, whatever I want, just to give me those 2 different checks. And that may be on this problem, that may be on another problem. Example 7. Let's do 7 together. 5 times 2 times 3 minus x minus 1 is less than or equal to 27. Yeah. Okay. As always, I have some options. I could start out by getting rid of that 5, but then I've got fractions. I don't think I really want to do that. Let's try distributing. We go to the inside thing. There's nothing to do with 3 minus x, so we distribute. That becomes 5 times 2 times 3 is 6, minus 2 times x is 2x, minus 1, less than or equal to 27. Now I've got some like terms I can combine. I can take the 6 and subtract the 1. Notice that I cannot, do not do this, I cannot add 1 to both sides to cancel that out. I cannot do that because this side is multiplied by 5 and this side doesn't have that multiplication by 5. So that's not a valid way of doing this, but I can simplify inside the brackets. 5 times 5 minus 2x is less than or equal to 27. Okay. Now, my choice, I can distribute or I can divide by the 5. I tend to distribute. So 5 times 5 gives me 25 minus 10x less than or equal to 27. I'm just going to check. I haven't multiplied or divided by a negative anywhere in here. So my sign should still be the same, and it is. Now, 25, that constant should be over here. Let's get rid of it. I have negative 10x less than or equal to 27 minus 25 is 2. Now, I've got a negative in front of my x. We're finally getting the chance to flip that sign. So this becomes x is greater than or equal to 2 over negative 10. Well, that's the same thing as negative 2 over 10, or I could even simplify it, negative 1/5. So quick note, whether we have the negative sign in the denominator, in the numerator, or just out front, means the same thing. So we have x is greater than or equal to -1/5. Go ahead, graph that, check your critical values, and then you can meet us on example 8. We have 5d plus 12 over 3 is greater than -4. This is one for you to work through. And example 9, we have 4 plus 2x over 8 is greater than or equal to 3. We can also have word problems. So let's take just a quick look at 2 word problems, and then there are more in the worksheets for you. Let's take a look. Okay. So Jamie's clinic. Jamie's clinic will break even for the day if the 15 doctors see at least 135 patients total. We want the doctors to see the same number of patients, and we want to at least break even. So the first thing that we're going to do is we're going to define our variable. I like to use P, maybe, for the number of patients. So I'm defining that, writing it out. If you like to use X, that's fine. X is the number of patients. Either way, you're going to write out what this variable means. Gives you some context. Now we need the inequality. The number of patients, 15 will be involved, 135 will be involved. Well, what's our bound? What are we saying? No more, no less, something like that. It's the 135. We say at least 135. Okay? And now we have 15 doctors each seeing P patients, 15 groups of P, multiplication. So we have 15 P, and we want at least 135. So at least 135 means it's okay if it's 135, and it's okay if it's bigger. I'm going to go 15P is greater than or equal to 135. There's our inequality. So on these, we're doing this very much step by step. It's very easy to get confused without that. Now we have 15P greater than or equal to 135. I just copied that over here. Let's get P by itself. I have is greater than or equal to 9. There's my answer. Justification for rounding if needed. Well, I didn't have to round. Sometime, if I had gotten 9.5 though, let's think about that. If I got 9.5, if I round down to 9, they're not seeing enough. So I would have to round up. If I got 9.1 and I rounded down to 9, it wouldn't be enough. So I'd have to round up. So you'll write in your justification for rounding if needed. If not, I'll just put an NA. You've got the solution of P is greater than or equal to 9. You have the graph. 9's our critical value. Let's put an 8 and a 10 here. Shaded or not? Pause it and think about it. Yeah, shaded. Going to the right because it's okay for them to see more patients. They just don't want to see fewer. And then the statement is a sentence that describes what you've just found and make sure that it's reasonable. Each doctor should see, I don't want to just say 9, I want to say at least 9 patients. So notice I've got my critical value in here. And I have my, my inequality language. Okay. Each doctor should see at least 9 patients. Take a moment, pause, and work on number 2. See where you get. When you're ready, feel free to start this video again, and we can do it together. Again, we can use any variable we want. If she's looking at how many candies, so how many candies starts with a C, I'm going to use C for candies. C is number candies. An inequality. Okay, 19 is my bound. I don't see any other numerals, any other numbers, but there's a 3 in there. Okay, that's helpful. 19. I have 3 kids. Each one is getting C candies. That's 3 groups of C. So we multiply again. And I want to make sure that I'm less than or equal to 19. I can't give away candies I don't have. I get yelled at for that. 3C is less than or equal to 19. So let's do the work. 3C, copy it over, less than or equal to 19. Divide by 3, divide by 3. I get C is less than or equal to 19 thirds, or 3 goes into 19 6 times, so 6 1/3. Okay, so C is less than or equal to 6 1/3. Now I do have to round. I'm probably not breaking up these candies. I guess it depends on what kind of candies you have, but we don't want to break these ones up. So let's round. And I'm going to round down not because 1/3 is close to nothing, but because if I round up, I'm giving away candies I don't have. If I round up to 7, I'm giving away 21 candies. I don't have that many, so I have to round down. Round down to avoid running out of candies. So my solution is now C is less than or equal to 6. My final solution is not the 6 1/3. My final solution has been rounded to 6. And similarly, I'm going to put my dot at the 6, not the 6 1/3. And my statement, think about that for a moment. Maybe she can give at most 6 candies to each child, or she can give up to 6 candies per child. There are a number of ways to say it. Now you'll go ahead and take a look at pages 103 through 108. We have several more word problems, and I want you to just kind of work through it like we did up here. And then we will take a look at exponential notation.